من المحور الثالث لمادة نظرية الآلات Theory of Machines. Here I will explain wrapping velocity at a pin joint. We have links connected by pin joints, link OA, link OB, and connected by a pin joint here. The links in a mechanism are mostly connected by means of pin joints. The wrapping velocity is defined as the algebraic sum between the angular velocities of the two links which are connected by pin joints, multiplied by the radius of the pin. So consider two links OA and OB connected by pin joint at O. Let W1 or omega 1, it is the angular velocity of the link OA, or also called the angular velocity of the point A with respect to O. And omega 2 or W2, it is the angular velocity of the link OB, or the angular velocity of the point B with respect to O. And also R is the radius of the pin here, the radius of the pin. According to the definition, wrapping velocity at the pin joint O, it is equal to what? Two cases are there. If the links move in the same direction, and it is the case here, okay, if pins, this is omega 1, omega 2, moves in the same direction, both OA and OB. Here, the wrapping velocity is equal to omega 1 minus omega 2 multiplied by R. Okay? Second case, if the links moves in the opposite direction, now the formula is for wrapping velocity is the following: omega 1 plus omega 2 multiplied by R. This is the formula if we have this configuration. Both links moves in the opposite directions. Note, when the pin connects one sliding member and the other turning member, the angular velocity of the sliding member is 0. In such case, wrapping velocity at the pin joint is equal to omega R, because we have only one omega, one angular velocity for one member making rotation, where omega is the angular velocity of the turning or rotating member, and R, it is the radius of the pin.